Hey, in this video I want to show you guys where the Pythagorean theorem comes from. I think if you can understand where the Pythagorean theorem comes from, then it helps you know how to use it, and it helps make the formula make more sense to you. So the Pythagorean theorem was discovered by Pythagoras. The years that he was alive is in BC, which means before Christ. So that was a really long time ago that they discovered this. And the Pythagoreans, they noticed something about right triangles, that something was always true. And this is what we call the Pythagorean theorem. It only works on right triangles, so that's the triangles that have a right angle. If it has a right angle in it, then it's a right triangle, and the Pythagorean theorem could be applied to it. In right triangles, the two sides that make that right angle are what we call legs. So we have a leg here and a leg here. Those are the legs of the right triangle. That third side, that diagonal line, it's always the longest side of a right triangle. It's what we call the hypotenuse. That's the hypotenuse, and it's the longest side, always the longest side of a right triangle. So let me show you something. I have a right triangle right here. I'm going to hold it up to a grid. So here's my side A, just like the one on the board, side A. I hold it up to my grid, and I see that side A is approximately 1, 2, 3, 4, 5, 6, 7, 8 units long. So I'm going to cut out an 8 by 8 triangle. Now if I were a professional videoer, I would have a graphic to show this, but I'm not, so not even going to try to claim. So here's my 8 by 8 rectangle. I may have said triangle a little bit ago, I meant rectangle. So here's my 8 by 8 rectangle that's the same size as this side that I had, okay? Now I'm going to do the same thing for side B. I'm going to hold this up here, and I'm going to see that it is 1, 2, 3, 4, 5, 6 units long. So I'm going to cut out a 6 by 6 triangle. So now I have an 8 by 8 to match that side, and now I have a 6 by 6 to match that side. Okay, now I'm going to do the same thing for the hypotenuse. I'm going to hold it up next to my grid here, and I'm going to see how many units long it is. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 units long. So I'm going to cut out a 10 by 10 rectangle, square, for that one. So here we have my 6 by 6. Here's my 8 by 8. If I can hold this for you. And then my 10 by 10 to match that side. Okay, so the whole idea is if I take these two smaller squares, this one and this one, if I were to lay them on top of this bigger one, you will see something amazing happens. See if I can do this. So I'm going to overlap this. There. Took my 8 by 8 and covered up my 10 by 10 as much as I could. But you see that I still have some red showing around there. So I'm going to use my blue rectangle. I'm going to cut it up and see if I can fit it in that space there. I don't have this done yet, so give me just 1 second. There's that. There's that. I take this onto there so I can show you. There we go. Take this one onto here, like that. I'm getting there. Okay, so what I've done is I've taken the two smaller ones. Oh, there I draw something. Hold on. I've taken my two smaller squares and I've cut them, and I want to show you that they totally and completely cover up that big square perfectly. So you can't see any more of the red. It all fits on there just right. So now let me go to the board and show you mathematically what I'm meaning. This side A was an 8 by 8 square that we had cut out. The area of it is 64 units then. 64 units squared. Hopefully you can see that okay. This other one was our 6 by 6. So the area of it was 36 units squared. Maybe that helps if I erase some of that. Okay. This last one was a 10 by 10. So you guessed it, the area is 100 units squared. I took these two smaller ones, my 64 and my 36, and I combined them. I added them together, and they equaled the area of this bigger one. So 64 plus 36 equals 100. And the Pythagoreans found that this happened all the time. If I took one leg and squared it and added it to the other leg that was squared, it would equal the hypotenuse squared for every right triangle. So this is where the formula comes from. If instead of thinking of this as 8 by 8, but instead the variable a by a, and the same with this one, think of this as instead of being 6 by 6, it is b by b. And the same with this one, instead of being 10 by 10, think of it as c by c. Well, when I found the area of this, that's a squared. And the area of this, then, is b squared. And the area of this, then, is c squared. And so we found that this is true, that a squared plus b squared equals c squared. I have some 8th graders that would prefer, instead of a squared plus b squared equals c squared, they think of it as, well, when I take one leg, so I'll use L, and square it, and add it to the other leg and square it, that's going to give me the hypotenuse squared. Leg squared plus the other leg squared equals hypotenuse squared, or a squared plus b squared equals c squared. Okay? So watch the next video that I'm going to put out there on how do we use this. Like, why would we want to know that? What is this good for? I'll make another one to show you that. Thanks.